This section will provide a short introduction to pressure and flow control valves and their operation. The relief valve is generally used in every hydraulic system. It is normally closed and is connected between the pump outlet and the reservoir. It is used to limit the pressure in the system to a preset maximum pressure. This is done by diverting some or the entire pump output to the tank when the pressure setting is reached. Here you will see an example of how a relief valve functions. The configuration and working method will vary depending upon the manufacturer. Port A is connected to the outlet side of the pump, and ports B and Y are connected to the tank. When the valve piston is closed, the pressure is the same at both sides of the valve, and it is held down by the spring in the lower chamber, closing port B. This means there is no flow through the valve. When the pressure on both the top and below the valve piston reaches the opening pressure of the small valve, it will open. Then there will be a pressure drop over the nozzle in the valve piston, and it will lift so that oil can flow from A to B. Pressure-reducing valves are normally open valves. They are used to maintain reduced pressure in certain parts of the system. They are actuated by pressure and tend to close as the pressure reaches the valve setting. In this valve, the direction of flow is from B to A. When the small valve is closed, the pressure is the same on both sides of the valve piston. The spring will hold down the valve piston and the valve is open. When the pressure reaches the opening pressure of the small valve, it will open. Then there will be a pressure drop over the nozzle. The valve piston will lift and flow from B to A will be reduced. If the pressure in port A becomes higher than the pressure setting of the valve piston will lift and close the port B. Port Y is connected to the tank. The unloading valve is often used in systems with 2 or more pumps. It can unload one pump when the required system pressure is achieved. Normally the valve is closed, but it opens when the pilot pressure is equal or higher than the preset opening pressure of the valve. This figure shows a system with 2 pumps. When the pressure is 6 megapascals, it will unload the large pump, and only the small pump will deliver oil to the system. Flow direction is from A to B. When the valve is closed, the oil pressure is the same on both sides of the piston. The piston is held down by the spring. When the pressure on top of the piston is equal to the preset opening pressure of the small ball valve, it will open. Oil will flow through the nozzle and there will be a difference in pressure on the piston. The piston will lift and oil can flow from A to B. When the ball valve has opened, it will remain open until pressure in port X is lower than the opening pressure of the ball valve. Normally the valve is closed in one direction and open in the other direction. To open the valve in the normally closed direction, one of these conditions must be present. Pressure at the entry must be equal to the preset opening pressure. Sufficient pilot pressure. Pressure at entry plus pilot pressure is equal to the preset opening pressure. The valve is normally closed from A to B and open from B to A through the check valve. The spring presses the valve against the valve seat, and the oil pressure in port A presses on the piston. When this pressure is high enough, it will lift the piston and oil will flow from A to B. The valve will also open if it is piloted in port X. Then the small piston will lift the big piston and oil will flow from A to B. The counterbalance valve is used to prevent creeping of heavy loads, prevent overload, prevent overspeeding and runaway loads, prevent accidents if pipes or hoses break. If a heavy load is placed on top of a long rod, it will move from side to side. To prevent the load from running away in either direction, a system of 2 counterbalance valves is put in place. The function is to control the oil flow, and thus the speed of the actuator. The valve is normally fitted after the direction control valve in order to prevent power loss. Flow control valves are essentially designed to control flow in one direction only, and are therefore provided with a bypassing check valve. The direction of flow is from P to A. By moving the piston downwards, it will choke the oil flow. If the oil flows in the opposite direction, the oil will press the piston upwards and flow unrestricted from A to P. This section will provide a short introduction to safety precautions and maintenance regarding hydraulic systems. Always read the safety data sheet for the hydraulic oil used in your system. Minimize skin contact with hydraulic oil. Do not use gasoline, solvents, kerosene or similar products to remove oil from the skin. Use soap and water. Do not wear oil-soaked clothing. Wash hands and face before eating. Clean up spilled oil promptly and dispose of it correctly. Avoid inhalation of oil mist vapors. Obtain medical advice on all potential health hazard problems. When you are disconnecting any joint or fitting in a hydraulic system, make sure that there is no hydraulic pressure in the system. Even if the pump is off, there can be pressure due to accumulators or external loads. Secure anything that might move when pressure changes. Move direction control valves through all positions, so all lines have a chance to discharge. The part being worked upon should be isolated from the power source and a warning notice displayed. After you have relieved all pressure, loosen lines slowly and carefully. Have rags and bucket ready. Use clean rags to wipe off hydraulic components. Absolute cleanliness is essential when working on a hydraulic system. The presence of dirt and foreign materials in a system can result in serious damage or inadequate operation. Replace all O-rings and gaskets removed during disassembly. Only replacement components that comply with the manufacturer's recommendations should be used. The 3 major dangers to hydraulic systems are contamination, heat, internal and external leakage. 75% of hydraulic failures are due to the hydraulic oil being in poor condition. Filter indicators should be monitored and filters renewed as required. Hoses have to be compatible with the oil in use and system pressure, and must be fitted without kinks or twists. Fittings should not be excessively tightened. During inspections, special attention should be paid to the condition of the filter, oil level, hot components, leakages, and any unusual noise from components. Points to be checked: oil level, suction strainer, all filters. Mounting bolts and brackets. Operating pressure. Oil leaks. Oil temperatures. Speed of the pump. During maintenance, these components should be checked. Filters. When a system is new, all filters should be changed after 50 hours. After this, the filters should be changed at regular intervals, or in the event of the dirt indicator on the filter indicating deflection. Pumps. Check temperature and noise when the pump is running. If the temperature is too high, inspect the pump. If the amount of oil leaking from the pump increases, the pump is worn. Pressure and flow control valves. Pressure valves. These valves should be checked for leaks. This can be done by placing your hand on the outlet of the valve. The pipe should be cool on normally closed valves. Also check that the valve is correctly set and that the adjusting screw has not moved. Volume control valves. Make sure that hydraulic actuators are moving at the correct speed and that the adjusting screw has not moved. Direction control valves. If cylinders are creeping, it can be due to wear in the direction control valve. Accumulators. The nitrogen charging pressure should be checked on a regular basis. Always use nitrogen when charging accumulators. Coolers, heaters. Air cooler. Check fan operation. Air from the cooler should be warm. Water cooler. If the cooler is not efficient, high oil temperature, the cooler may be clogged. Heaters. Check set point and operation. Oil. The oil level should be checked on a regular basis. If you refill, always use the same oil as previously used on the system. Drain condensation water from the bottom of the tank on a regular basis. Pipes, hoses. Check all pipes and clamps. Check hoses. There should not be any mechanical wear or damage.